Okay, today we're talking about motion under gravity with air resistance. Now I'm talking about the theory first. Later on I show you the video. Okay, if you graduate from IGCSE, this is not a new thing for you. But if you are graduate from SPM, this is new thing. Okay, but it's okay. Here, air resistance, sometimes we call it as drag. You need to know that air resistance will increase when your speed of the object moving is increases. So you imagine if you're working, you cannot feel any air resistance. But if you try to run, then you can feel the air resistance. Okay, so air resistance will increase when the speed increases. Okay, so this is the graph velocity time graph. Okay, for the diver. So we are going to study every single motion, every single velocity time graph. Why we get this kind of shape? Okay, for the graph. So we look at the A first. So I divided into A, B, C, D, E, and F step. So we look at the A step here, starting here. Okay, this one starting. So when starting, you jump out. Okay, jump out from the airplane. So or whatever. Okay, here. So at here, there is no air resistance yet. The only force acting on the object or you is the weight. Okay, there is no air resistance as such. Okay, so they will accelerate at 9.81 meter per second. Starting no air resistance yet. Okay, so it will accelerate. The only force acting on the object is the weight. Okay, accelerate means what? Speed increases. Okay, accelerate meaning that speed increases. So when the speed increases, just now we mentioned air resistance will increase. Okay, so let's say I just put some value so that you easy to have a look. Okay, let's say this one is 80 Newton. So this one, the resultant force is sorry, not 80, 800 Newton. Okay, so right now the 800 Newton is your weight. It won't change. Okay, it won't change, but now your air resistance increases, start to increase. Okay, let's say at here I put 100 Newton. Okay, so from this, put some value is let you for more clear. Okay, have a picture more clear. So you look at this, your resultant force right now becomes 700 Newton. Actually, your resultant force is decreases. Am I right? It decreases. So F equals to MA. If your resultant force decreases, of course your acceleration right now won't be 9.81 anymore. It will decreases also. Okay, resultant force decrease, so your air acceleration also decreases. Okay, because right now we start to have air resistance. Okay, then at C at here, step number C at here. Okay, so at start at here, we accelerate. Then after that, our acceleration decreases. Okay, so this is B. We still increasing the speed, but with a lower rate. Okay, so this is A, B, and C. Velocity unchanged. Why? Okay, we look at the C at here. Okay, just now I got mentioned the air resistance will increase when the speed increase. Second case B, we still accelerate. So that means that air resistance will keep on increasing until when? Until it is balanced. Okay, the air resistance balance with the weight. So 800, the upward air resistance also 800 Newton. So your resultant force at here becomes zero. They balance out. So there is no resultant force acting. Okay, so when no resultant force, last week I got mentioned, it become balance. Okay, it become balance force. Okay, the force become balanced. They will have no acceleration. Okay, so they will have two possible motion. One is maybe object at rest, or maybe object moving, but moving with constant speed. So at right now, because the object is moving, it's moving downward. So this motion is constant velocity. It should be moving with constant velocity when the upward force and downward force balance. So the 800 Newton is the weight, air resistance pointing upward also 800 Newton. At this moment, object is moving with constant velocity. So at here, we got spatial name for this constant velocity. We call it as terminal velocity. Okay, so at here, see at here, constant velocity. Okay, now I'm going to talk about the D. Suddenly, we open the parachute. Okay, here, suddenly we open the parachute. So at here, your weight still 800 Newton. Your weight cannot be changed. But suddenly you open the parachute, your upward air resistance or upward force become bigger. Let's say like it become 1000 Newton. So right now, upward force is bigger than your weight. You won't move upward, dear. You are falling down. So you are decelerate. You will slow down. You are not going to move up. Don't confuse about this. Upward force is bigger, but you still falling down, but you slow down. Okay, slow down. That means that your velocity decreases. So refer to the graph, okay, motion graph. Can you see that suddenly from 50 meter per second suddenly decrease to something less than 10? Okay, it's because the upward force at here is greater than downward force. Until what? Okay, since we know that it decelerate, that means that slow down, then your air resistance also will decreases because right now you slow down. Okay, slow down until they balance again. Okay, they balance again. So at this moment, we will achieve another lower terminal velocity. Okay, so at here I repeat, because we slow down. So when we slow down, air resistance will also decreases because our speed decreases. Okay, it will affected by our speed until it balance again. Balance again. Can you see that here? We achieve another lower terminal velocity. At this constant velocity, or we say terminal velocity, is when the force upward and downward, they are balanced. Okay, so at here until at the end, continue until she hit the ground. Okay, so this is how the whole process is happening and then how they achieve the terminal velocity. Now I'm going to show you the video. Shay, maybe what? Okay, right now. So okay, so right now, starting is 0 because haven't jumped. After jump, it will accelerate. Okay. Well, I want to show with this value 1. Okay, start to jump only have weight. Okay, this green arrow showing the weight. So at start, we only have weight, so we are accelerate. Okay, we are accelerate. Then at the same time, the red color is showing you air resistance. It will start to increase, 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 increase because our speed is increases. So can you see that speed is increased, but it's not that fast in the decreasing rate. Okay, until at a moment they balance the air resistance and the weight balance, so it's still falling down, but it's falling down with a constant velocity, which we call it as terminal velocity. Okay, continue. Then suddenly open the parachute. Then upward force suddenly bigger than the downward weight, bigger than the weight. Okay, the air resistance suddenly bigger. Okay, at this moment, you still continue falling down, but your speed decreases, decelerate. Okay, When you decelerate, your air resistance will continue decreases because of your speed until another moment that balance again with a lower terminal velocity. Okay, so until the end, it stop. Okay, so stop share, come back to the worksheet. Okay, so any of you got any question before we start with the past year question? Any question? If you got question, then you type in the chat box. You type to the Newton Scholar there. If no, then you respond to me. Then we start to do the past year question. No question, thank you. Okay, like boys and girls, 2018, a stone of mass m is dropped from a tall building. There is significant air resistance. Okay, so we need to consider the air resistance. The acceleration of the free fall is g. When the stone is falling at constant velocity, what is the information is correct? Okay, 10 seconds. 10 seconds. Do it and then type your answer to me. Let me have a look. At constant terminal velocity. Okay, Vashini already get the answer correct. Okay, so when constant terminal velocity, last week we got mentioned balance force. So your upward force, your air resistance must be equals to your weight. Okay, let me check for our answer. B correct. Fatima B. Good job, dear. Okay, here answer is B. Okay, when terminal velocity acceleration is 0, okay, the force of gravity m0, force of gravity meaning that the weight, this is weight, okay, the air resistance should be equal to your weight. It balance, okay, so answer is B. We go to the second question. Okay, okay, we go to the second question. Like 5 seconds, try. A, B, C, D. Which region of the graph show parachute at terminal velocity? Again, terminal velocity. When terminal velocity meaning that constant velocity. Okay. A, B, C, D. Fawal correct. Kaichen no. Try again. Washini correct. Fatima no. Try again. Okay. If you choose D, you see this is a distance time graph. This is a distance time graph. If you choose D, meaning that at here they are not moving. This is not moving because the distance does not increases. So it's not D. Okay. So constant velocity meaning that it is moving with a constant speed. Okay, or constant velocity. So at this question, your answer should be boy. Answer should be boy. Okay, this is distance time graph. If you choose D, that is not moving. Okay, so we go to the question number 3. Question number 3 a bit challenging, but it's okay. Okay, a person stand on the edge of the high cliff that is next to the sea. Okay, maybe we can draw it out like this. Okay, like this. So somebody standing here, then throw the something up. Okay. Then throw a stone vertically upward. Air resistance. Okay, air resistance. So we need to consider air resistance. And at the end, it hit to the sea. So this is the sea. Okay, something like this. Okay, which velocity time graph best show the motion of the stone? Okay, so at here, at starting, when it moving through upward, the velocity should be increased or decreased. Think. You throw something upward, velocity should be increased or decreased. Then after that, when the object goes to the maximum height, then it will go down. So this one velocity should be increased or decreased. So think. And then, does they change direction? Because velocity have to consider direction. So after you think, then you tell me what is your answer. Prasan, correct. You are answering this question, right? Number 3. Fawal, no. Consider the direction. Fatima, correct. We don't know. We don't think about the direction. Prasan, correct. Okay, Vashini, correct. Okay, dear, if you choose D, that means that you didn't think about the direction. Okay, so we settle one by one. Okay, here we throw something upward, velocity should be decreases. Then this one, velocity should be increases. Okay, then one more important thing is, these two, they are different direction. One is throwing upward, one is falling downward. So that means that our velocity time graph will involve with positive and negative area. So if like this, C and D confirm wrong because they only involve positive area. That means that there will be these two motion is meaning that they are in the same direction, moving in all the time in the same direction. So C and D is wrong. Then you look at this, positive here, negative. Positive here, negative. That means that it changed direction. So A and B, which one is the correct answer? Answer is B. Why B? Because we need to consider air resistance. If A is no air resistance, okay, B is with air resistance. Okay, so if we draw the line to show the direction, to show the gradient, so you look at this this one, from maybe negative whatever negative 10 or whatever, so decreases 10 decreases to 0. Okay, 10 decreases to 0. So we put this as negative direction, put this as positive direction. Okay, then we found that the gradient actually decreases. So that means that this part is decelerate, slow down. Okay, then here like this. Okay, this part is because the air resistance. If you choose A, that one is without air resistance, that will be correct. So at here, question said that we have to consider air resistance, so you have to choose B. Okay, C and D confirm wrong because they didn't consider the direction is already changes. Okay, Fawal correct. Okay, next we goes to the question number 4. My dear, we goes to question number 4. You read it and then you type your answer in the chat box. Number 4. Same mass. Rasan correct. Good job. Okay. Snowflake experience a larger drag force. Okay. Meaning that it can be achieved terminal velocity faster or slower. So you have to think. Washini correct. Okay. So if it will experience having a greater drag force, that means that the upward force is greater. So it will be easily achieve terminal velocity. Okay, which means that the raindrop will take more time to achieve. Will it achieve? It will, but it takes times because the drag force is smaller. Okay, Fatima, correct. So we go to the question number 5. Which one is the correct answer when we achieve constant velocity? Actually, it's mathematics. Rearrange the formula. Find the V. Vashini, correct. How about others? Vowel, correct. Okay, constant velocity. That means that resultant force is zero. Upward force equals to downward force. So at here, 0 equals to mg minus kv square. So kv square equals to mg. V equals to mg divided by k, then square root. Answer is C. Okay, we go to question number 6. Question number 6. Actually, this one is just test your idea. Do you know what happened when the constant velocity? Resultant force is 0, acceleration is 0. Okay, upward force equals to downward force. Okay, number 6, 2022. Projectile is launched at an angle, okay, then it reached the maximum height at position X. Assume that there is no upthrust acting on the projectile. Which diagram show the direction of the forces acting at position X? So you have to think. Okay, here there is a keyword A. In the A, so we need to consider the A. Okay, so how many force acting right now on this position X? How many force? So, what is your answer? Every object must have weight. This one confirmed. Okay, every single object will have weight. Okay. Not A. Where is the air resistance acting on? Not A. Where is the air resistance acting on? Air resistance is actually what can I say? Air resistance actually is a force. Okay, it's a force. But well, no. Vito correct. No, not D. Not C. There is air resistance. Have to consider air resistance. Washini, no. Vowel correct. Okay. Kai Chen correct right now. Jore. Correct, Jore. Prasan correct already. Yue Ting. Okay, B correct. Right dear. Answer is B. Okay, right now, where is the object moving? Like this, like this. This is the direction of motion. This is motion. Motion is not a force. Motion is not a force. So air resistance always oppose your motion. You are moving in this direction. Air resistance should be oppose your motion. So this is air resistance. Answer should be B. Okay, this question will trick you. Okay, we goes to number 7. Right dear, number 7. This is the velocity time graph that we very familiar. Okay, starting like this, then terminal velocity, then suddenly decrease the speed, then after that, achieve another lower terminal velocity. Now, what is the related acceleration time graph? Like boys and girls, try. You have to think, starting, what's going on with the acceleration? What's going on with the acceleration? Then at here, what's going on with the acceleration? Then after that, what's going on with the acceleration? Okay, then you choose A, B, C, D. Vowel correct, good job. How about others? From the velocity time graph, think about the acceleration. Then after that, you find what is the acceleration time graph is correct. Okay, start at here, acceleration, still accelerate, but with a lower rate. Okay, with a lower rate. Fatima, correct. Good job. Okay, then after that, when we achieve terminal velocity, our acceleration becomes 0 because we balance. It's constant velocity, balance. So this one and this one are 0. Then this one, acceleration, actually we call it deceleration because speed is decreases. So which one is correct? Vito, correct. Like boys and girls, answer will be B. Okay, let me highlight the terminal velocity. When A equals to 0, this one A equals to 0, from P to Q, from R to S is correct. Okay, this one here also correct. Okay, then here is is acceleration, but decreasing becomes 0. Answer is B. Answer is B. Kai-Chen A. Okay, Kai-Chen here because it decreased sharply. Okay, so this one is much more suitable. This one is only decreased a bit only. Okay, so B is the more suitable answer. Okay, we go to the next page, page number 8. Okay, velocity, easy. Velocity actually is the displacement divided by time. I already teach you guys, per unit time we call as rate. Rate of change of displacement. If you write rate of change of distance, we can give you wrong, because velocity is vector quantity is due to the displacement. Okay, here. A constant driving force. Okay, let me draw it out. So we will have a driving force, 2,400 Newton, acting on the car of mass 1,200 kg. The car accelerates from rest. So at here, one information, U equals to 0. Okay, assume that the resistive force is negligible. Oh, okay, we ignore. So there is only 2,400 Newton. Calculate the acceleration. So what is the A? Easy. You see, we already have resultant force. Then we got the mass. Then we want to calculate acceleration. This question too easy. Okay, 2,400 Newton equals to 1,200 is the mass times the A. So at here, your A should be 2.0 meter per second per second. 2.0, two significant figure. Okay, this one is easy. Then here, number on figure 3.1, sketch a graph showing the variations with time of the velocity. Oh, you are going to sketch the velocity for the first 20 seconds. So at here, one information is the time, 20 seconds. Okay, maybe I can write again the information. U equals to 0. Okay, at start at rest, then the time is 20 seconds. It accelerates at 2.0 meter per second per second. Now we want to find the final velocity because this is velocity time graph. Do you able to find it out? And then using what formula to find it out? You look at this UTAV. Easy. Type in the chat box. What is your final velocity? What is the final velocity? What formula you can use? 40, thank you. Okay, thank you, 40. 40, yes, thank you, Yue Ting. V equals to U plus AT. Yue Ting T. I think T is your surname, right? I should call you Yue Ting. Okay, dear. V equals to U plus AT, or we can using A equals to V minus U over T. After you do substitution, this is 2 equals to V minus 0 divided by 20. So your final is 40 meter per second. So your graph should be like this. 20 seconds at the end, it achieves 40 meter per second. Okay? Label this line A. So this one is A. If you didn't label, we also can deduct your mark. Okay. Is it okay? We proceed to the page 9. Okay, here. In reality, a resistive force, because just now this case, we assume there is no air resistance. Because at here, we assume no air resistance, no frictional force, whatever is perfect case. That's why it can be accelerate, okay? Nice, just a straight line. Okay, in reality, there is a resistive force due to the air resistance acting on the car in B. The resistive force will increase with speed until it become equal. Okay, until it become equal in magnitude. This is the meanings of we achieve constant speed. Terminal velocity. Of course, at here, if horizontal moving, we didn't call it as terminal velocity lah. Okay, falling down one, we call it as terminal velocity. Here we just said that they're moving with constant speed, or we say they're moving with constant velocity. Okay, so at here on figure 3.1, sketch a second line to show the variation with time t of the velocity v of the car for the first 20 seconds of its motion. Label this line B. Okay, so at here, see, at time equals to 12 seconds, they achieve constant velocity. Okay, we come back here. We can find at any point as long as our line which is lower than this. Okay, it must be lower than just now, because just now the one is perfect case. Right now is they are not perfect, got air resistance, so it must be something like this. And then at 12 seconds it achieve horizontal, which means that constant velocity. So at here, after 12, I can choose any point lah. For example, at here, after 12, it must be horizontal. Because after 12 here, 12 seconds here, they achieve constant velocity. Okay? So at the front here, you just draw something. Cannot. My drawing too bad. Slightly curve a bit. Something like this. It will be lower than the just now line A. And then they also asking you to label this as line B. So read the question carefully what they want. If you draw very nice, you didn't label, also useless. Okay? Okay, you can choose any point and then horizontal. Then at the front, you just connect it. Slightly curved like this. Okay? Then here we go to the next here. At time equals to 20 seconds, the driving force increase. Okay, at start, let me have a look. Starting just now, we said that it's moving forward with 2,400 Newton. Then after that, air resistance increases to balance. Okay, just now the case is like this. Right now is after 20 seconds, this force become 3,000 Newton. Okay, so this one is just starting is still 2,400. Suddenly we accelerate. Okay, suddenly we move it faster. So what's going on with the velocity? Just now I already told you the answer. When we increase the driving force, so that means that the object velocity will increases, right? How describe how the velocity change? The velocity will increase. Why? Because here, the resultant force, right now we got resultant force already. For example, this one, our resultant force equals to MA. So your resultant force right now is 600 Newton. Of course, you having the value for A. That means object accelerate. Accelerate meaning that velocity increases. Okay, so just now in this case, resultant force is 0. Acceleration is 0. It's moving with constant velocity. Okay, but here is 2 marks, so we need to continue to describe. Since here 3,000, you speed up. Then don't forget about air resistance. Air resistance, because right now you accelerate again. So the air resistance will continue increases. Okay, it will continue increases. So at here, until a certain moment, we will increase to achieve another another maximum velocity, maximum constant velocity, another maximum constant velocity. Okay, answer scheme also accept if you say terminal velocity lah, will achieve another new terminal velocity. Okay, the behind one is for you to practice. If you're facing any problems, actually you can private message me. I will show you the working step. Okay, the answer already provided at the bottom part. Okay, boys and girls, you take out your lesson number 12. We're talking about momentum. Is it okay? If okay, then type in the chat box. Then I will go to the new lesson. Thank you, Vashini. Bảo, thank you. Okay, Kai Qian. Okay, good job. Okay, dear, behind practice, then we go to momentum. Okay, momentum. This one we know already. It's a product of mass and velocity. Product means times, okay. Then at here, because momentum we involve with velocity. So velocity is vector, momentum also a vector. If vector, we need to consider not only magnitude but also direction. Okay, so at here, before the collision, we goes to the right. So we can put this as positive. Okay, so we put this as positive, but when after it collide, it rebound to the opposite direction, although the speed still 2 meter per second, but right now velocity, we should put a negative here. We should put a negative. So this one positive, change direction, we put a negative. Okay, so sometimes if you want to say teacher goes to the right, I put negative, then goes to the opposite direction, I put positive, can or not? My answer is yes. As long as the another opposite direction, we put negative, that's all. Okay, we can set to the right as positive, to the left as negative for velocity, or you want to change here negative to the right, then goes to the left as positive, doesn't matter. Okay, it's okay. So we go to the next page. This one we already know, so we can go through very fast. Okay, this have to memorize. Okay, total momentum in the closed system is remain constant provided there is no external force acting on the system. There is no other force acting on the system. Okay, momentum before collision must be equals to the momentum after collision. So collision we divided, actually got three cases lah. One is elastic collision, inelastic collision, and also one more is the what we call the explosion. Okay, the explosion. So boys and girls, you look at this, elastic collision. Elastic, that means collide, they will separate. Okay, highlight the keyword of separate. Elastic, after they collide, they will separate. Okay, inelastic, after they collide, they will combine and then move together. This is called inelastic. Okay, so the table at here I already show you. Formula no need to talk because we already learned. Okay, in IG, in SPM we learn. Okay, momentum for elastic collision, momentum, total energy, kinetic energy, all conserved. But for the inelastic, total energy is conserved, but total kinetic energy is not conserved. Okay, so some of the I mean that the kinetic energy after collision will be smaller. Some of the energy actually will be converted to others form, for example heat or sound. So if we're talking about total energy before and total energy after the collision, does they conserve? Answer is inelastic, not conserved. Some of the kinetic energy already changed to others form. So at here, this one, I make a table for you to be more easier lah, okay? So for the elastic one, all conserve. For the inelastic, momentum conserve, total energy conserve. This one, total kinetic energy before and after not conserve. Okay, we go to your page number 3. Okay, this one important. Okay, next. Elastic. There is one something new for our AS. Okay, this one previously we didn't learn. Okay, I want you highlight perfectly. If elastic collision is perfectly, okay, it can be not perfect, okay, but for perfectly, we need to follow this rule. The relative speed of approach and relative speed for separation. This one is approach, this one is separation. It must be the same. Relative speed meaning that the speed of one object measured in compared to another one. Okay, so at here, how we calculate the relative speed? If the object moving with opposite direction, then we add it up. If they're opposite direction, we add it up. If they are in the same direction, then we're using the bigger one minus the smaller one. This is the way how we calculate the relative speed. Okay? Then if elastic, we will fulfill this conservation of kinetic energy. Okay? So kinetic energy before 1 over 2 mu square plus 1 over 2 mu, mu square plus 1 over 2 mu square, these two kinetic energy plus it up together equals to this kinetic energy plus this kinetic energy. Okay, kinetic energy, the general formula for kinetic energy is 1 over 2 mv square. So this one is just the kinetic energy for object 1, object 2 before the collision. Then this one is kinetic energy for the object 1 after collision, object 2 after the collision. Okay, so today the new thing is the number 2 and number 3. Okay, so we look at this. Okay, here, A, B, C, D. Which one collision is perfectly elastic? Like boys and girls, which one? Can be answered in 10 seconds. Elastic. For this word elastic, you can cancel out two answer already. Fawal correct. Vashini correct. Good job. Okay. Boys and girls, you look at these. These two, after collision, they are combined. So they are actually inelastic. So these two can be cancelled. No. Confirm no. Then C and D, what is our answer? Okay, what is our answer? So just now we said perfectly, then they fulfill this or fulfill this. But the calculate the conservation of kinetic energy is more like more works to do lah. Okay, so we're using the relative speed lah. So you look at these two, they are in opposite direction. So the relative speed for these is 3 meter per second. Add it up together. Okay, then for this one also opposite direction, so this one will become 5 meter per second. They are not the same, so they are not perfectly elastic. Then the D line, 4 and 1, 4 and 1 in the same direction, so we're using 4 minus 1. It should be 3 meter per second. Okay, same direction we're using minus, opposite direction we add it up. Okay, this one is also same direction. 4 minus 1 is 3 meter per second. So answer is donkey. Okay, answer is donkey. Correct, Kai Chen? Okay, so perfectly elastic. We can using relative speed. This is much more faster. Okay, but if they didn't mention about perfectly elastic, then we're using the conservation of kinetic energy much more safe. Okay, so we go to the next, like boys and girls. Okay, two bar magnet P and Q. Okay, they are on the float here. That means that they can move without friction. Okay, two magnets slide towards each others without making contact. Relative speed is equals to the relative speed of separation. This sentence can tell us what? Can tell us that this is a perfectly elastic collision. Okay, so A, B, C, D, what is your answer? Fawal, correct. Good job. Vashini, correct. How about others? Do you able to get the answer? Fatima, correct. Answer at here should be donkey. Okay, the kinetic energy before and after should be equal. Okay, should be equal. C is incorrect. Momentum of Q after collision. After collision is equals to momentum of P before. No, because at here M1 U1 plus M2 U2 equals to M1 V1 plus M2 V2. You cannot say that. Let's say this is P. This is P. The P before interaction is equals to the Q after. No, we cannot say so. We cannot say this and this are the same. Okay? They total up P and Q before equals to the after P and Q. That is correct. But before collision P equals to after collision Q momentum. No, this is a wrong statement. Okay, like boys and girls, we go to the number 3. If for momentum, I will draw out the diagram. Not draw, simply sketch lah. Okay. So at here, a start is 80 kg. So another one is 40 kg. So before collision, the heavier one move to the right. So I draw it out 2 meter per second. And the lighter one move to the left 1 meter per second. After the collision, the heavier one moves to the right at 0.8 meter per second. Okay, so this one we don't know. So we are going to find this. Okay, we are going to find this. What is the V2? Okay, what is the relative speed of the separation? Okay, so boys and girls at here, because they didn't mention about the perfectly, so we need to calculate the V2 first. Then after that, the relative speed of separation, we using V2 either if they are same direction, then we're using V2 minus 0.8. If they are opposite direction, then we add it up. So now your task is you have to find out what is the V2. So this question not difficult. So I want you first job finding out your V2. M1 U1 plus M2 U2 equals to M1 V1 plus M2 V2. Find out V2 for me before we go to the relative speed. Vowel C not correct. Vashini, correct. Your V2 already find out. Then what is your relative speed of separation? V2, if you do it correctly, you should get 1.4 meter per second. Vashini, correct. Okay, so this one 80 times 2 plus, oh, maybe I know why you wrong. Here, did you put a negative? Did you put a negative? It's moving in opposite direction. Okay, in moving in opposite direction. Forget to put a negative. So at here, I encourage you, if something wrong, you make mistake right now, then you're using highlighter, highlight it. So next time when you do revision, you will pay attention about that. So this one should put a -1 equals to the mass unchanged 0.8 plus this one is 40 V2. So if you do it correctly, your V2 should be 1.4 meter per second. But boys and girls, this is not our final answer. Question asking you relative speed of separation. So separation, that means we look at this. Okay, you see, V2 is positive, is positive. That means that the directions is to the right. Okay, it's same as the previous, okay, because we set to the right as positive. So at here, separation, relative speed. So this one, answer should be, this one should be 1.4 meter per second. So this one should be 1.4 minus 0.8. Why minus? Because they're having same directions, so we minus. Okay, then our answer should be 0.6 meter per second. Answer should be A. Yes, Kai Chen, correct. Okay, now boys and girls, we go to the next question. Okay, I proceed. Don't forget about the direction. Okay. Then here, This one is 2024, 5,000 kg towards to the right, 2 meter per second, 5,000 kg to the left. Okay. One is traveling with the 2 meter. Oh, okay, this is the speed law. Then another one is in opposite. Like boys and girls, put a negative because opposite direction. Velocity have to consider the negative. Velocity have to consider positive or negative. Depends on direction. Okay, join together. After that, they will join together. So two objects will join. Okay, what is the kinetic energy loss? Okay, now here we got the mass M1, U1, M2, U2. Now we got the M1, U1, M1, no, M1 and M2. So we got the, after collision, the mass. But the problem is we don't know the V. We don't know the V. So I need you to calculate the V first. Because we need to calculate the kinetic energy, we have to know the velocity. How much kinetic energy loss? That means that we have to find kinetic energy before and kinetic energy after. Then we minus it, then we know that how much the energy is losing for kinetic. So boys and girls, can you calculate the V first? After collision, what is their common velocity? Right, boys and girls, do it. And then type out your answer. When they combine, so they will, we can assume they become one object. So the mass we just add it up together. Yes, correct, Vashini. If you do it correctly, your V, you should able to get 0.5 meter per second. Okay, Vashini, you continue to find how much, what is the kinetic energy loss? Don't forget about the direction, -1. It becomes -1. Okay, what is the kinetic energy loss? Boys and girls, calculate the kinetic energy before and calculate the kinetic energy after. Finding out how much is losing. Any of you got the answer? Let me check. Correct, Vashini. Jore, correct. How about others? Do you able to get the answer? So you calculate the kinetic energy before. So you calculate kinetic energy for this, then kinetic energy for this, and then it's here, because kinetic energy doesn't have any direction. Energy no need direction. Energy is a scalar quantity. So right now, your directions, your velocity, positive, negative, doesn't matter. Okay, we don't need to consider the velocity. We consider the speed. Okay, kinetic energy is a scalar quantity. So we no need put -1. Okay, Fawa, correct. Okay, so at here 1/2, 5,000 times the 2 square plus 1/2, 5,000 times 1 square. No need -1 because this is energy. So at here 12500 joule. Then this one 1/2, 5,000 plus 5,000. The final velocity is 0.5 square. So your answer should be 1250 joule. After collision, we left 1250 joule of the kinetic energy. So kinetic energy loss 12500 joule, lost 1250 minus, then we lost 11250 joule. Okay, let me highlight something. So this one, velocity is for us to finding because we want to count for this. Kinetic energy after. Okay, then this one, here we need to minus 1. But for the energy, no need to minus 1. No need. Energy is scalar quantity. Okay, so for this question, answer is C. Okay, should be no problems. Then we go to the next page. Page number 6. Answer C. We go to page number 6. State the principle of conservation of momentum. Okay, so this one, total momentum for a closed system, total momentum is constant provided there is no external force acting on the system. So if we come back to this question, can you see that at here, frictionless track? There's no friction. If you got friction, you got air resistance, there's external force already. So they don't consider external force. So when we're applying the conservations of momentum, we assume that there is no external force acting on the system. Okay? So at here, this one you copy at the front. Okay? For the core system, the total momentum is constant. Okay, provided there is no external force acting on the system. Okay, boys and girls, this one for you to try by yourself. Ball X and ball Y are traveling along the same straight line in the same direction. Okay. Mass 400 grams for ball X. Horizontal velocity is 0.65 meter per second. Then for ball Y is 600 grams. Horizontal velocity is 0.45 meter per second. Then catch up, collide. Then that diagram is their information. Calculate the total initial momentum for the two ball. Like boys and girls, do it. Initial momentum. What is your initial momentum for the two ball? At the attendance. Type your answer if you get the answer. For a while, no. There is one something important you forget. Something you didn't convert. Correct, Washini. Correct, Kai Qian. Prasan, correct. Jore, correct. Fatima, no. You forget to change. Like boys and girls, initial momentum. Okay. So at here, that means that M1 U1 plus M2 U2. Remember, the mass have to convert to the kg. So here, this one should be 0.4 times 0.65 plus 0.6 times 0.45. So your answer at here should be 0.53. Okay, they got two units. At here, can you see that Newton second? Can be Newton second or it can be 0.53 kg meter per second. They are the same. Okay, but why NS? NS is because we got another formula that we learned called impulse. Ft equals to mv minus mu. Remember? So this one, mass times velocity is kg meter per second. Then force times time is Newton second. So these two units are the same. And then, teacher, why we need to convert the gram to the kg? I don't want to change. Is it okay or not? My answer is not okay. Why not okay? Newton second. These two, they are SI unit. SI unit. That means that when you do substitution, all the value must be in SI unit. For mass, SI unit is in kg. Mass is velocity is meter per second. Okay, so no choice, you have to convert. Okay, you have to convert. If you make mistake at here, then you using highlighter, highlight it. Then you write down kg. Next time when you do revision, you go through with the worksheet, then you will pay attention about this. Okay, like boys and girls, here they don't know the V. Can you calculate the V? Calculate the V. Fatima, is it okay? 0.53. I think you forget change the kg. Okay, good job. Like dear, calculate the V. How you calculate? Momentum before equals to momentum after. Good job, Prasan. Correct. Hmm. Vashini, yeah, Vashini, the second one is correct. Fawal, correct. Okay, momentum before is 0.53. After at here they split, here this diagram, they separate. So same thing, we continue. This one is 0.4 times 0.41 plus 0.6 times V2. So your V2 should be 0.61 meter per second. 0.61. This one 0.53. Okay? This question actually is same like we do the MCQ, but they split out step by step. Okay, so before momentum, called initial momentum of the two ball, actually is initial before collision. What is the total momentum? Then you are going to find the V, so we can apply the principle of conservation of momentum. That means that momentum before collision equals to momentum after collision. Okay, like boys and girls, we go to the next page. Can you calculate the total kinetic energy of the two balls? Let me have a look. Okay, calculate the kinetic energy for the two balls. Count before. And then you can also count after. See whether they will be the same or not. Oh, Prasan, you means that page number 7, this total kinetic energy, is it? Actually, both can be accepted. But I will write 0.15 in two significant figure. 2 to 3 can be accepted in your answer scheme, but most of the time the answer scheme they will provide it in two significant figure. If you write 3 also correct, but then I try to get used to two significant figure. Your answer is correct. Okay, so boys and girls, calculate total kinetic energy for the two ball. So 1 over 2 m 1 u1 square plus 1 over 2 m2 u2 square. Fawal correct unit. Vashini correct. Fatima, no? Check which step you make mistake, Fatima? So here 0.65 square plus 1 over 2, 0.6 times 0.45 square. So at here, your answer should be 0.15 joule or 0.145 joule. Okay, both can be accepted. For me, I will using two significant figure. Okay, any of you got check about the kinetic energy after collision? 0.15 Kai Chen, correct? Okay, any of you got calculate after collision total kinetic energy? Explain how you would check whether the collision is elastic or not. Okay, how we know? Basically for elastic, We can base on the kinetic energy to know. Same also, thank you Vashini. If you calculate after collision, kinetic energy after collision, you also get 0.15 joule. So that means that we fulfill just now the starting theory. I go back to theory here, this one. Can you see that? How I know this is elastic or not? Because the kinetic energy is conserved. Okay? Kinetic energy before equals to after collision. If we calculate this, then I will know that, oh, they are elastic. If they are not elastic, for example, this case, can you see that they join together? The kinetic energy will lose. They will change to other form. So this one is inelastic because kinetic energy does not conserve. Okay, so at here, this one, how we know? Okay, we can calculate the kinetic energy before and after. If they are the same, then we know they are elastic. Okay, so at here, we write it down. Total final kinetic energy equal to the total initial kinetic energy. Okay, if you check about, you can also check about the relative speed of approach, whether equals to the relative speed of separation. If they are perfectly elastic, then they also fulfill the requirement. Okay, they will also fulfill the requirement. Relative speed of approach equals to the relative speed of separation. Okay, let me check 0.61 minus 0.2. Okay, if I go to the front page here, so this is approach. What is their relative speed of approach? Okay, so this one same direction, so I using 0.65 minus 0.45, so it should be 0.2 meter per second. Okay, so how about after? This one is the relative speed of separation. Okay, this one will be V. Just now we calculate the V is 0.61. They also same direction. So I also minus. So at here, this one relative speed of separation will be 0.61 minus 0.41 equals to 0.20 meter per second. So boys and girls, can you see that? If I'm using this method to check whether they are perfectly elastic or not, also can. Because of their relative speed of approach equals to the relative speed of separation. So I can confirm they are elastic collision. Okay? So now there is two answers. Either one will be correct. So I just write one answer. Okay, next. Now it's about Newton's third law. Ask you to use Newton's third law to explain why during the collision, change in momentum of x is equal and opposite to the change in momentum of y. Okay, so Newton's third law is talking about the force acting on two objects. They must be in the same magnitude but opposite direction. Okay, so it's talking about the force. So at here, if force related with momentum is mv minus mu over t. Okay, this is the impulsive force. Because we're talking about Newton's third law, so we have to talking about the force. Okay, then at here, if I arrange, because now the question asking you change in momentum, so force times t equals to mv minus mu. Okay, first, okay, force during collision will cause a change in momentum. Okay, force during the collision will cause a change in momentum. Why? Okay, here, second sentence that you can score the mark is, okay, here, second, the force on the two object or bodies are equal magnitude, same magnitude, and opposite direction. Okay, so we're talking about the Newton third law, huh? Newton third law here, Newton third law here. The force acting on two objects, equal magnitude, opposite direction, like this, you score 1 mark already. Okay, here, they collide, the contact time must be the same. Two objects, they collide, they're having the same contact time. Okay, so at here, and we have to mention the time of collision is the same. Okay, so third sentence we have to mention. So can you see that here? This force is same magnitude but opposite direction. Then the time in contact is the same. So of course your change in momentum, it will having the same magnitude but opposite direction. Okay, so at here, the last sentence, therefore, the change in momentum must also be equal and opposite direction. Must be equal magnitude and opposite direction. Okay, they're asking you why momentum x and y, they are equal but opposite direction. So ask you to relate it with Newton's third law. Newton's third law is talking about the force acting on two objects. They're having same force but opposite direction. Same magnitude of the force but opposite direction. Okay, so the time is the same. The time doesn't change because two objects they contact. Of course, they're having the same contact time. Okay, so when your force at here is same magnitude, that means that the change in momentum also the same, but then opposite direction. So this is the answer. Okay, I want to go to your page number 8. We have to speed up. Right, boys and girls, we go to page number 8. Is it okay? Finish writing? Okay, thank you, Vashini. Okay, boys and girls, a block X slide along a horizontal frictionless, okay, because we don't want external force, towards to a stationary block Y. So the diagram showing you block Y, block Y starting is stationary. So of course stationary momentum, starting momentum is 0. So there is no momentum here, okay? Then after that, the collide, okay, it moves towards to the block X. So they collide in contact. After contact, they will be collide and then separate. So that means that at here, look at this, that means that at here, this one is before collision. It still remain as stationary. Then this part, what's going on? Okay, this part, what's going on? This part is when they collide. When they collide and contact. Then after that, they start to having a constant momentum is because it's moving with a constant velocity. So this one is after separate. Collision after separate. Okay, so at here, this is the, let me have a look. At time equals to 0, block X has momentum. Okay, starting this one is the momentum. Later on, they will ask you to sketch block X, momentum for block X. Because right now they're giving to you is only block Y. Okay, we look at the next question. Define the linear momentum, easy lah. Product of mass and velocity. Use formula, no need to memorize. P equals to M times V. M times meaning step product. Okay, determine the time interval. Determine the time interval when the blocks are in contact with each other. So how long the time they contact each others? How long the time? Just now I already explained to you. Look at the unit, dear. Look at the unit carefully. Okay, so at here, this one is before collision, in contact. After that, they separate. After that, it separate, it having its own velocity, constant velocity. So that means that this part to here actually is a time they contact. So boys and girls, this is millisecond, millisecond. So at here, your answer should be 40 millisecond. 100 millisecond minus the 60 millisecond. That is the time for the block they contact. Okay? So it will start to accelerate. Okay, describe without any calculation the magnitude of the acceleration of block Y. Okay, acceleration of the block Y from the time t 80 meter per second to 100 meter per second. Okay, we look at this. 80 to 100, is it this one? Okay, they're asking you to describe what? Acceleration. Acceleration is meaning that speed up or maybe decelerate, slow down. So that means that it will involve with velocity. So you look at this, velocity change or not, dear? Velocity change or not? What do you think? Type in the chat box. Let me know. Velocity changing or not? What do you think? From 80 to 100 millisecond, velocity change or not? Momentum change, velocity change or not? Let me have a look. But wow, yes, velocity increase. Okay, why? Because momentum increase. Momentum change, momentum become increases. Momentum is mv minus mu. That means that final here momentum is higher is because of the velocity higher. Okay, the mass does not change. Mass does not change, but the speed is increases. That's why momentum increases. Speed increases. That means that your acceleration, it should have acceleration. It will have acceleration. The acceleration should be constant acceleration because speed increases. Okay, so this one behind is the reason. Change in momentum, or I say momentum is increased. Momentum increase, momentum increase. Meanings that your speed increase. Speed increase, that means that accelerate. Okay? Change in momentum is mv minus mu. So that means that this one, v is higher, is increasing the speed. Okay, how about the 100 millisecond to 120 millisecond? What is their acceleration? So we look at this here. What is their acceleration? So my question is, does your speed changes or not? Thank you, Vashini. Your acceleration should be 0. Why 0? Because momentum does not change. Momentum does not change, that means that your speed doesn't change. Your velocity doesn't change. So it is a constant velocity. This one is constant velocity. Okay, so at here, your acceleration should be 0. Okay, so here we write 0. Reason is no change in momentum. What does it mean? Meaning that your constant velocity. Okay? Okay, boys and girls, we need to find the force acting on the block Y, on the block Y. Okay, force. Formula force related with the change in momentum, because here this diagram is changes of momentum divided by time. So for this one, we should find change in momentum divided by the time. Use the figure 2.2. Find the magnitude of the force exerted by the block X on the block Y. So we are calculating the force on the block Y. So you look at this. How you calculate? Calculate it out and then tell me. Change in momentum divided by time. So actually, you can calculate from graph easily. We can either two only, find gradient or find area under the graph. So you go and check which one can bring the information that you want. Okay, so at here, try to find out change in momentum, because this part is the contact. This part is during contact. So the force exerted on the block Y is during the contact. This one is already spread out. No more force acting on the block Y due to the block X. So we should finding this part. Find the gradient. The gradient will be Y-axis divided by X-axis. Okay, calculate and then tell me what is the force, resultant force. Correct. Make it two significant figure, Jory. Correct, Vito. Fawal. Oh, Fawal, I know your problems. Millisecond. Millisecond. You have to convert the milli. Remember the unit. Prefix. This is called prefix. Tera, giga, mega, kilo, deci, centi, milli, micro, nano, pico. You have to convert the prefix. Okay, so at here, if you're using the gradient 0.50 divided by the 40 times 10 power of negative 3. 40 millisecond. This one, M is times 10 power of negative 3. So your answer should be 13 Newton. Correct, Fawang? Yes, Vashini, correct. So 13 Newton. Okay, when they're asking you to get some information from the graph, basically, we can think about the gradient, think about the area under the graph, and check what information we want. Okay, so here on the figure 2.2, sketch the variations of the momentum of block X. This is what I mentioned just now. They only provide you Y, block Y. Then they're asking you to draw the momentum time graph for the block X. Okay, is it from 0 to 160 millisecond? Okay, starting momentum 0.40 kg meter per second. But the problem is, I don't know the final momentum for the block X. Can you calculate it so that you're able to plot the graph? Okay, so I know starting is 0.4. So I know starting 0.4 until 60. Because until 60 at here is the time they contact. So I draw at here until here, 60 second, millisecond. So initial 0.4. But the problem is I don't know my final. Can you count the momentum for the block X after collision? Count it up. I want to know the block X after collision. The momentum for the block X. So that I can sketch the graph. Okay, so block X. So there is block Y, block X. Now I want to know momentum after collision. Yes, Vito, correct. So you complete the graph first while we're waiting for others to try. So boys and girls, calculate the M1 V1. I want to know about the block X after collision. What is the momentum so that I can sketch the graph? I want to go down, but I don't know where should I go. Okay? So boys and girls, try. So before is M1 U1 plus M2 U2 equals to M1 V1 plus M2 V2. Okay, so this one starting is not moving, so this one is 0. So this is 0.4 equals to the M1 V1. I want to know this. M1 V1, the final momentum after collision from block X. Okay, then what is M2 V2? What is the momentum for the block X after collision? Fawal, correct. But the unit is wrong, Fawal. Unit for momentum. Okay, so at here, block Y after collision. How I know, teacher? Here we know. Block Y after collision is 0.5. This value we get from the graph. Okay, so at here, M1 V1, the block X, it should be negative 0.1 kg meter per second. So that means that after collisions, it should be negative 1, 0, negative 1, 0 at 100 seconds. Okay, here, it should be maintained after collision. So we combine these two lines. Okay, this should be block X. Okay, so 60 seconds at here before collision. Then until 100 millisecond here. This one is during contact. Okay, the contact. So here to here is after collision. Okay, boys and girls, any question for this? If no question, then we are going to the next page. Any question? Thank you, Kai Chen. Thank you, Vashini. So we go to your page number 10. Okay, Fawal, good job. Okay, right there, we go to the next page. Now, just now is one dimension. Now as we learn two dimension. Okay, but this one, my worksheet got one mistake here. Okay, the principle of conservation of momentum can be applied to the collision in two dimension. So before collision, I have M1 and M2. M2 is moving, but here my worksheet, when I typing, I lost out. So please help me to add M2U2. Okay, I missed out this. Okay, dear, after collision, they have certain angle. Okay, certain angle. So at here, we need to separate into x-axis and y-axis. Okay, x component and y component. So at here, in your x direction, it will be m1 u1 plus m2 u2 equals to the m1. Then you see this. We should make it how we say, make it change to the x-axis. Okay, so how we change the angle in between? So we using cos. It's something same thing like we calculating for the force, same thing. So at here, m1 v1 cos theta, the angle between these two, so we using cos, plus m2, then v2 cos this symbol. Okay, so this is how we finding the x-axis. Y-axis, if y-axis before collision only horizontal, so they will have no vertical before the collision. So the collisions for the y-axis we only can consider after collision. Okay, so at here, this one M1 V1 angle not in between them, we're using sine. Okay, M1 V1 sine theta, so this is y-axis for the M1. Then M2 V2 sine the angle here, this is the direction pointing downward. So one upward, one downward, it should be equal. No others. Because before only having horizontal. Now before is 0, so after the collisions, M1 going out, we split out into the x-axis and y-axis. The direction will follow. Okay, so let's say this is point. So this direction for V1 is pointing outward. When we split out, this direction is pointing outward. This one also pointing outwards. Okay, pointing, follow the V1 direction. Then the bottom part also the same. V2 pointing like this downward. So this one pointing downward, pointing out. From this point, out, out, out. Okay, with this knowledge, we try with the past year question, right, boys and girls? But the first question, a bit, I guide you. Okay, first question, I guide you. So a snooker ball have a mass of 0.2, has 0.2 kg, has a collision, so that its direction of movement changed by an angle. Okay, this one is before collision. After collision, it becomes 90 degree. The ball has a speed of 0.4 before collision and a speed of 0.3 meter per second after collision. What is the magnitude of change in momentum? Right there, underline change in momentum. Formula mv minus mu. Okay, boys and girls, can you calculate momentum mu first? Mu 0.2 times 0.4, we get 0.08 kg meter per second. This one is before collision. Then we also need to calculate after collision, mv. mv is the mass doesn't change. Although here they didn't label, but we also know that this is 0.2. Okay, times 0.3. So our answer is 0.06 kg meter per second. We count out mv, we count out mu. Now they want change in momentum, mv minus mu. So your mv will still the same, going up. This is mv, which is 0.06 kg meter per second. Now, do you still remember? Minus mu, minus. This is the direction for mu. But right now we got minus. So what should we do with the vector? Okay, so at here minus, that means that right now our directions for the mu should be changed in opposite direction. So this one, I use red pen. This should be changed direction. Minus, that's why mu we change direction. Change direction for our mu. First lesson or second lesson, I can't remember. We're talking about this. Okay, the vector, minus the vector, so the direction have to change. Just now, 0.0x is pointing to the right. Now we minus the mu, so we need to be opposite direction. So here, mu is 0.08 kg meter per second. What is the magnitude of these two? Magnitude something like resultant, so we need to find out this. What is this? This one you can using mathematics Pythagoras theorem to solve it. Okay, the triangle to solve it. Can you calculate and then tell me your answer? Let me check. Correct, Vashini. Prasan, correct. Good job. How about others? Okay, magnitude. Correct, Hai Qian. Good job. Okay, dear, here we can using the one your mathematics Pythagoras theorem. The one says C A B, so your C equals to A squared plus B squared. We can using this method. Okay, to find out the change in momentum. So at here it should be 0.0 x squared plus 0.06 squared. So your answer should be 0.10 kg meter per second. Answer should be B. This question actually they want to test on you. Do you know MV minus MU? Because this is a vector. When they minus, the direction have to change. Fatima, correct. Okay. So we goes to the question number 2, page 11. Goes to page number 11 here. An object X of mass 0.3 hit, then after that collisions, so they will have certain angle. This one is quite similar with the diagram that I show at here, the theory part. Okay, here. What is the value of V? So all the information is here. So, okay, we can consider the X direction. So X direction. Momentum before equals to momentum after. So at here, mx plus m2my uy. So this is before collision. Then this one mx. Then the speed cos 60 degree because x at bottom part. Okay, plus the my v y cos 41. Okay, then after that I put some value in 0.3 times 3. Then the my starting not moving. Stationary. They got mentioned at here, stationary. So this one we no need to consider. This one stationary 0. Okay, so it will be equals to 0.3 Vx. Okay, the x is at the bottom part. So at here 2 cos 60 plus my, 0.5. My is 0.5. Then the v we don't know, cos 41. Okay, boys and girls, you calculate and then tell me your answer. Okay, you might asking, teacher, why we calculate y-axis? Is it possible we can calculate and get the answer using y-axis, y direction? My answer is yes. If you using y direction, you will also get the answer for v. No problems. Okay, boys and girls, calculate and then tell me your answer. We resolve it, dear. We resolve it, This one is the previous chapter already. We resolve it into the x-axis, same direction. V cos 41 degree, 2 cos 60 degree. Let me check. Any of you calculate already? Vashini, correct. How about others? Vashini, since you finished already, you can try with the y-axis. Then I look at others' answer first. Correct. Fawwa correct. Fatima correct. Kai Qian correct. Jore correct. Like you all can answer. So answer will be 1.6 meter per second. Okay, I left it for you. You can continue to try with the y direction. After that, not right now. Okay, because before the collision, we don't have. Then after the collisions, we split it into the Fy here. Not Fy, momentum y. then here. You can calculate at the end. You can also get the same answer as V equals to 1.6 meter per second. You can prove it by yourself. Okay, I want to go to the next page. Prasan, correct. Lydia goes to the next page. Two balls, X and Y, move along a horizontal frictionless surface. Okay, the ball X have the mass. Actually, the all diagram is very clear already. Okay, the ball collide and stick together. After collision, they were moving together with 3.7 meter per second. By considering the component of momenta along the line AB, calculate delta. Oh, they want you to calculate the directions, the angle. Like boys and girls, do your calculation and tell me. Same thing, you have to do calculations for the x direction. Okay, do it and then tell me your answer. Do calculation and then tell me your answer. Resolve. Resolve meaning that split. Okay, split into the x direction. Split into x direction. Then we all compare the same direction, x direction. So you need to resolve it. Rashini, correct. Good job. How about others? Do you able to get the answer? Type your answer here. 4 meter per second with certain angle, so we need to resolve it into x-axis. Then 4.8 also resolve it. Fawal, correct, good job. How about others? Boyang, today I didn't saw Boyang. Suddenly remember you. Yue Ting okay or not, Yue Ting? Yue Ting, do you able to get the answer for this question? Vito, correct, Vito. Good job. Okay. Yes, Kai Chen, correct. 32. Okay. So you solve it by using mathematics. At the end, you should get 32 degree. 32 degree. So basically, it's the same thing as this, but just now it's giving you the angle. Right now is same method, but the angle is unknown. Okay? So boys and girls, by calculations of kinetic energy, state and explain whether the collision is inelastic or perfectly elastic. Like boys and girls, based on kinetic energy, you don't base on the relative speed. They already say calculation of kinetic energy. So can you count? Calculation the kinetic energy, no need to consider direction anymore because this is energy. This is energy. So no need to consider the direction, the angle we ignore. Let's do calculation and then tell me the answer is inelastic or actually perfectly elastic. Junho, today okay or not, Junho? Jahan okay or not, Jahan? Okay. Okay. Jahan, try to calculate the kinetic energy and then tell me the collision is inelastic or perfectly elastic. So at here, kinetic energy is scalar quantity. No need consider the angle anymore. Just use the mass, use the speed. That's all. Do calculation before collision, total up. After collision, total up. Compare. If they are inelastic, what happened with their kinetic energy? If they are perfectly elastic, what happened to their kinetic energy? Washini, correct. Washini, you type out. Tell me what is the initial kinetic energy and final kinetic energy that you get? How about others? Do you able to get the answer? Correct. Kinetic energy before. Okay, will be 1 over 2 m1 u1 square plus 1 over 2 m2 u2 square. Before collision, we got two objects. Okay, then after that, 1 over 2, 3 times 4 square plus, let me check who else able to get the answer. Wow, correct. Okay, 1 over 2, 2.5, 4.x squared equals to 53 joule. Like boys and girls at here, kinetic energy is scalar quantity. No need to consider direction. We're just using this and this, using the magnitude. Okay, we're using speed, not using the velocity at here. No need to consider direction. Okay, so at here, kinetic energy after collision, 1 over 2 m1 v1 square plus 1 over 2 m2 v2 square. 1 over 2. Oh, okay, because they combine, is it? Oh, they combine. They combine, we can just using the mass that combine. After. So m1 plus m2 v square. So 3 plus 2.5, 3.7 square. Your answer should be 38 joule. Like boys and girls, there is one important thing is here. Can you see that the final kinetic energy actually is less? Because some of the energy lost to others form. Yes, Kai Tian, your answer is correct. They are belongs to inelastic collision because the kinetic energy does not conserve. Okay, kinetic energy after collision is less. Okay, some of the energy already changed to the heat or sound. Okay, boys and girls, we go to the page number 13, the last question for today. Should be no problems, huh? Okay, then we go to page number 13. 6 minutes. Like boys and girls, I give you 3 minutes to complete. For this question, you need to consider y direction and x direction. Okay, you need to do something like simultaneous, then put this and the unknown variable put in, and then cancel out, mathematics solve it. Okay, go to the page number 13. If I didn't guide you, do you able to answer? Okay, because there is some unknown value here, so you need to using the y direction and x direction. Then the variable, you do some substitution, mathematics, actually more on mathematics. Like boys and girls, 2 minutes. You do? You need to using x direction and y direction. something like simultaneous to solve the problem. See, any of you can get the answer or not? This question more on mathematics. Two more minutes. Any of you able to solve it? In 2 dimension. Oh, they are so nice. They told you have to consider in X dimension and Y dimension. Okay, we got two unknown. We got two unknown. V and W. Yeah, Jore, correct. But which one? V is which one? W is which one? V is okay, correct. But I get 2.88. Dear, I get 2.88. Is this some calculation? My part? I didn't round off? But your answer is correct. Right, dear, for those who cannot solve, here we got two unknown. Okay, because I directly use calculator. Oh, okay. That should be fine. Okay, this one, we got two unknown. So you have to solve by using your mathematics. Okay, you have to solve by using a mathematic. So this one we can put like arrange V equals to 3m W sine 30 degree divided by 2m sine 30 degree. So your V should be 3W divided by 2. With this, do substitution in here. So you continue solve it. Now I guide you until here already. Right, dear? Try. Continue try. This is mathematics, right? Two unknown, two equation. Then you're using the V equals to 3W divided by 2. Substitute in the V. Finding out the W first. Any others get the answer? I'm waiting for you. Except Jory. Jory already complete. How about others? Substitute V equals to 3W over 2 into the second equation. This is first. This is second. Prasan, W, no? No? Check your working step. Any part you do wrong substitution or not? So at here, W for me, because M and M can cancel out. So my W should be 1.92 meter per second. Then your V should be 3W 1.92 divided by 2. So my V should be 2.88 meter per second. But here when you fill in, don't fill in wrongly. Like dear, this is my working step and you check. W equals to 1.92, yes. Then 2.89. Oh, then that means it's me. My problem is it? So 2.89, right dear? 2.89. Two of you calculate 2.89. Then should be my, maybe I do calculation wrongly. Oh, maybe because I using 1.92, is it? Oh yeah, I using, okay. So no problem. Okay. Jewelry. Yeah, oh okay. Okay. Yeah, should be fine, no problem. It depends on what the value that you use for the working step, no problem. You show out. You show out you're using the 1.92, then you get 2.88, no problems. Okay, how about others? This question, is it okay? For me, I think this question is more like mathematics solving. Physics part is the front one, y direction and x direction. Cannot find MW cos 30. Find M. Find M. Which part? 2 plus 3 not 5 me. 3W cos here. Is it? Washini, is it here? Because 2M and 2 cancel. 2M and 2 cancel, so 3W cos 30. Here, this one, I substitute in here. 3W over 2. So here is 3W cos 30 plus 3W cos 30. Here, M. 3MW cos 30. How about others? No need to be shy. Is it okay? If okay, then we will end our lesson at here. Let me have a look. One more message here. Kai Qian. Okay, get it. Oh, good job. Mathematics, right? This is mathematics. The physics part is at the front only. Then after that, how you solve it is using a mathematics skill. Okay, any other question? If no question, we will end our lesson right now.